Yeah, so hello guys. In this video, we will be starting with sorting. First, we will see about bubble sort, how bubble sort works, right? This is be our first sorting algorithm, bubble sort, right? It's a very basic sorting algorithm. Yeah. So, suppose we have an array and the array is 4, 8, 7, 1 and -2, and we have to sort this array, right? So in bubble sort, what we do now, we will compare these two adjacent elements, and we will check if ARR of I, if ARR of I is greater than ARR of I plus 1, then we will swap these two. We will swap ARR of I and ARR of I plus 1, right? Because it's obvious, like if the I plus element is smaller than the ith element, then we should move it at the first position or at the lesser position, right? So that's how we will move in this array, and after each pass, the element, the highest element will go to its right position, right? So we will see how this is working, right? So let's start. We are here as of now. Okay. So we will write first pass, first pass. Okay. We are here 4, 8, 7, 1 and 2. Our I is here. We will check if I ARR of I is greater than ARR of I plus 1. No. Let me also write the pseudo code with this also, so it will make more sense. For int I is equals to 1, I is less than n, and I plus plus. And for int j is equals to 0, j is less than n minus I and j plus plus, right? Here we will check if this same condition, if ARR of uh, j is greater than ARR of j plus 1, then swap ARR of j and ARR of j plus 1, right? So this will be the pseudo code for bubble sort. We can refer to this while we are doing. Yep, so we are here at I is equals to 0. We are not starting with I is equals to 0 here. We are starting from 1. Why we are starting from 1? Because we will check the first element with all the elements, right? So, sorry. Yeah. So the I pointer we will have not at 0 but at 1. So our I is here. Here 0, 1, 2, 3, and 4. So I is here. We will check I is less than n, right? The j will become 0. So j is here, right? J is here. Now we will check if j is less than n minus I. What is n? N is 5 and I is 1. N minus I is equals to 5. 5 minus 1 is equals to 4. So j is less than 4. That's correct. So what we will check if ARR of j and j plus 1, if ARR of j is greater than ARR of j plus 1, which is not right. Right, so we will increment j. J will be here, and again we will check 1 is less than 4. Right, so we are here. We will check if ARR of j 8 is smaller, is greater than ARR of j plus 1, which is 7, which is true. So we will swap these positions, 4, 7, and 8. These two elements I have swapped, 1 and minus 2. This is our new array. Okay, so the I was here and the j we move to here. After swapping, j is here. Now we will check if ARR of j is greater than j plus 1. Yes, that's correct. So we will swap these two elements, 4, 7, and 1, 8 minus 2. Right? So our I was here at 1 and the j was at 2. Now j is here. Again, we will check if ARR of j is greater than j plus 1. Yeah, it's correct. So we will swap these elements. 4, 7, 1, uh, minus 2, and 8. Yeah. So our j is now here. J is here. That means j is 4. So this condition will become false. 4 is not less than 4. So we will exit this inner loop, right? And this is our array. So after this first pass, you can see the highest element is moved to the last of the array to its original position, right? That's what why we see say bubble sort, because the higher elements will move backward and the lower elements will move forward, right? This was our first pass. Now we will run for second pass. Second pass, right? This is our array and now our I is at index 2. So I is here and j will start from 0 again, right? Okay, let me I'm trying to scroll this up a bit. Yes. Yeah, so here we are. The I is here and J is here. We will check if AR of J is greater than this. No, it's not greater. So we will move the J pointer here. We will check if this is greater. Yes, this is greater. So we will swap these two, 1 and 7. Right? Now we were having at 1. Now the J is here. Right? And I is also here. I is also here at 2. We will check if this element is greater. Yes, this is greater. So we will again swap these two elements. 4, 1 and -2 and 7 and 8. J is here. Now J was having 2. Now we will check if this element is greater than this. No. We will increment J and we will exit the inner loop. So we are done with the second pass also. Now we will run this for third pass. This is our array for 1, -2, 7 and 8. As of now, this is our array. J will be here and last time I was at index 2. Right, so now it would be here at index 3. So we will check if this element is greater than this. Yes, this is greater. So we will swap 4 and 1. So 4 J will be here and -2 and 7 and 8. Now we will check if this element is greater than this. Yes, this is greater. So we will again swap these two elements. 1, -2, 4 J is here, 7 and 8. Right. Now we will check if this element is greater than this. No. So J will move to this. This is greater than this. No. J will be here and we will exit the inner loop. Third pass is also done. Now fourth pass. The array is 1, -2, 4, 7 and 8. I we were having at index 3. Now I will be at index 4 and J would be here. Right. So we will check if this element is greater than this. Yes, this is greater. So we will swap these elements -2 and 1 and 4 and 7 and 8. Right. So our J is now at here. Now, if you see our array is sorted, so it will move here, J will move here, and J will move here, and the outer loop condition will also false, right? So in our pseudocode, as you can see, why we were starting from 1, right? Because if the size of the array is 5, we if the n is 5, we only need 4 iterations. We only need 4 iterations, which is n minus 1. So that's why we started from 1 and move to n minus 1. Or you can start from 0 and here you can mention n minus 1. Right. And this loop was running n minus I uh, times because we have already sorted uh, that part, the first part. right? If you see here, j was having 4, n minus 1. Okay, okay. So this condition, I guess we missed because we run up to n only, right? So every time we are uh, checking if the value of j is incrementing. So for when I was 1, it was 4. When I was 2, when I was 2, here I was 2. So n minus I would be, n was 5 and 2, so 3. So it will run up to 3. Why? Because the last element is already at its right position, the correct position, right? And when the I was 3, n minus I would be 5 minus 3 is equals to 2. Because why? The last two elements are already sorted. The last two elements are already sorted. So we will only check for 0, 1, for 0 and 1, two elements only, right? Similarly, for the fourth iteration, n was I was 4, so we can say n minus I minus 1. So it will run for one iteration only. Yeah, so this was the optimization I forgot from the pseudo code. Yeah. Uh, there are few things about bubble sort which uh, we we have to remember. The first thing is the bubble sort is stable. Bubble sort is stable. What we mean by stability, the relative order of elements after sorting remains the same. For example, this is our one array, elements of our array. After sorting, the array will become 1, 2, 3, 7, 8, 8, 8, and 9. Right, so these elements, if I mark an asterisk, a plus and a minus, then these order will be as it is, which was there before sorting. Yeah, so bubble sort is stable. The second thing is it's adaptive. Now, what we mean by adaptive means if the output is partially sorted, if the output is partially sorted, then we can skip the unnecessary iterations or compares. Now we can use a boolean flag here. We can use a boolean flag to check uh, if the element is already at its right position, then we can skip the exceeding iteration or the iterations of the current value of j. Okay. Third is use case. Bubble sort is suitable for small data sets because of its time complexity, which is big O of n square. Big O of n square is for average and worst case. For best case, it is big O of n, right? When the array is almost sorted or partially sorted. The space complexity is big O of 1. We are not using any auxiliary space. So this is in place sorting algorithm, right? Uh, the drawback is it's not suitable for large data sets due to its high time complexity. Not suitable. Not suitable for large data sets. Okay. Yeah. So this was all for this bubble sort algorithm. Uh, one more thing we can discuss is how we can use the Boolean flag to optimize our number of iterations, right? So we can modify the existing pseudocode which we have written here. Now, what we can do in this pseudocode, we can say, let me quickly write the pseudocode. Uh, we can say optimize pseudocode. Oops. Hmm. So what we will do, uh, we will check, we will have a Boolean flag here. Boolean flag by the name, any name we can take is swapped. If swapped is equals to false, the initial value which we will have is false. Let me write f on. Now we will run the inner loop for int I is equals to j is equals to 0, j is less than n minus I and j plus plus, right? So if ARR of j is greater than ARR of j plus 1, then we will swap ARR of j and ARR of j plus 1. After this, what we will do is we will make this Boolean flag as true. This will be update as true. We will close this and close this inner loop, and here we can check if is swapped is equals to false, then we can break the iteration, right? Now how the code will run according to this, right? So for the first pass we are here, right? So we will make this flag as false, and once I swap this with the adjacent element, this is swap, we make this as true. Now, so yeah, it means if none of the iteration in the inner loop is swapped, that means the element is already at its original position. Then we can break the outer loop and say our array is sorted, right? For if for any of the iteration. After any of the iteration, the jth iteration will not go into this loop for any iteration. It means our array is sorted now. So we don't need to do any other comparison and sorting. So we will check if the flag is false, then we can break. Yeah, guys, so that was all for this bubble sort. Thank you. Thank you for watching.